Hi, everyone. As I promised last week, I would like to explain to you an example of a critical path methodology as part of schedule management. Remember that we're talking about the scheduling management, and we have 6 processes. Process number 1, plan schedule management. Process number 2, define activities. Process number 3, sequence activities. Process number 4, estimate activities durations. Process number 5, develop schedule. And process number 6, control schedule. Why I'm doing this introduction? Because before we move to the example of the critical path, this is like a foundations in order to understand the concept and then eventually apply these concepts to the CAPM exam. So the first technique that we're going to study today as part of this example is the PDM. What is the PDM? It's a schedule network diagramming technique in which activities are represented by boxes, and we saw a couple of examples last week. So when you see boxes and arrows, the boxes are the activities and the arrows represent the logical relationship between activities. So the scheduled activities are graphically linked by one or more logical relationships to show the sequence in which the activities are to be performed. And this is something that we already studied last week, and we put some examples. So this is an example of a PDM. We have this project, and it's a very small, I would say a small example, because we have here only 6 activities. And of course, we need to add the start and finish nodes. The arrows represents the relationship between activities. If I say, for example, what is the relationship between activity B as in boy and E as in Edward, I can tell you that activity E cannot start until B finishes. So this is very important because every single example and every single question that you may see in the exam will be the finish to start relationship. Okay, what are the 4 dependencies that we talked about this class last week? Finish to start, this is just to refresh the concepts. Finish to start, finish to finish, start to start, start to finish. As you can see here, this is an example. These are the examples of each relationship. The good news is that for critical path purposes, we only will be focusing on finish to start relationship. However, you need to understand for the exam the idea and the concept of finish to finish, start to start, and start to finish. So that's why I'm providing here in the next page the full definition. So I'm not going to reading these definitions because for the exam and for this example, the only relationship that we need to apply is the finish to start dependency. So what is the definition of that one? It's the logical dependency where initiation of the successor scheduled activity is dependent upon the completion of the predecessor scheduled activity. So this is something that is not new for us, and we saw this concept last week. Let me continue. Let me just continue because before the exercise, before the example, we need to explain a couple of terminologies. So number 1, PDM, it's the technique, okay, to represent the schedule, the network of the project graphically. So the PDM is a technique. Number 2, the CPM is the critical path methodology that we're going to explain today during the exercise that I'm providing at the end of this session. So the critical path, it's an scheduled network analysis technique used to determine the amount of flexibility, which is the float. The float, it's an asset is the time that you can delay any activity without delaying the final project implementation date. So let me explain to you better with the example. So the critical path, by definition, is the sequence of scheduled activities that determines the duration of the project. And this is the objective of this exercise, is understand what is the duration of the project based on the critical path methodology using the PDM diagram. So by definition, the critical path is the longest path through the network. Also, is the shortest time in completing all the activities in the project. So it's not a contradiction. It's the longest path. However, it's the shortest time that you can complete all the activities in the project. And I have to demonstrate that to you doing this beautiful example that I have for you today. So what is the total float? What is the total slack? The float or slack, which is the same, is the how much time you can delay any activity in the network without delaying the final completion of the project. So to me, it's an asset. It's a resource that you can use in terms of how much time can I delay this activity. So it's just for you to be able to make smart decisions during the execution of your activities on the project. So let me continue. So until this page, we provided the PDM definition, the CPM definition, the critical path definition, and the total float definition. Those four terminologies are very important for the exam. So in order for us to understand the critical path methodology, we need to just to move forward and define the representation of any single activity in the network. This square that you see on the screen, it has different, I will say, terminologies. ES is the early start. EF is the early finish of that activity. A is the name of the activity. X is the activity duration. LS is the late start of the activity, and LF is the late finish. Why is this important? Because we will be defining every single activity based on this chart. So for each activity in the network, we will be calculating the early schedule and also the late schedule of the calendar. So you will see with the example will be more clear. However, we need to understand the formula to calculate the total float. The float for each activity is equal late start minus early start. Also, you can use the other formula which is there, which is late finish minus early finish. And there is also that you need to know is that we need to calculate the forward pass using the early schedule, which is in the top line of this square. And also we will be calculating the backward pass, which is the bottom line, is the late schedule of the network. So Lisa, this is too much. No, this is just a representation of each activity in the network. When you see the example, it will be more clear. So let me move forward. This is the question number 1. You are the project manager on a construction project and you are building the network diagram. Activity A here is providing the duration. This is something that you will receive. You will receive as part of the exam. And remember, this is a simple network diagram. As you can see, only 4 activities: activity A, activity B, activity C, and activity D. So if you read this carefully, you will see that the CAPM exam is providing all the information you need to calculate the critical path, the total float, and also determine the early schedule and the late schedule of your project. So activity A, the duration is 5, and activity C, the duration is 2, Activity B, the duration is 2, and activity D, the duration is 6. However, this example is not only providing the duration, but also the relationship. So the activity A and activity C, they said they can start right away. So they don't have any predecessor. So there is no a previous activity before activity A and C. So this is something that you need to use in order to create the diagram. So the activity B can start just when activity A and C are finished. So I'm telling you right now that activity B, it's dependent on activity A and C. And activity D can start after activity C is finished. So you have every single information you need. This is the input that you need to create the diagram. The good news is that maybe you don't need to create a diagram. Maybe they will provide the diagram. So just to start the execution or resolving this example, it's clear that we have 4 steps in order to calculate the critical path method. It is 4 steps. Step number 1, forward pass. Step number 2, we need to calculate the backward pass. Step number 3, we need to calculate the total float. And step number 4, we need to identify finally, which is the objective of this exercise, is just calculate the critical path or identify the critical path. So let me just start with the step number 1, which is forward pass. The activity A, remember, we need to calculate 4 values for each activity, starting with forward pass like step. So activity A, the earliest start, it just is part of the input that you already have on the previous page. The earliest start is 0. Why? Because they can start right away, A and C. So the duration of activity A, it's 5. So the early finish of activity A, it's 0 plus 5. 0 plus 5. We are executing right now the forward pass, which is step number 1 to calculate the critical path. So activity C, the earliest start of activity C is 0. The duration of activity C is 2. So the early finish of activity C is 2. Why? Because activity C can start right away and the duration is 2. So when is the early finish date of activity C? Is on the day number 2, and activity A is the day number 5. So after that, I need to do the same with the rest of the activities of this network, which is activity B and activity D. So the activity B can start only when activity A and activity C finished, okay? When they're finished, now I can start executing the activity B. So based on the rules that we have on the previous page, we need to select the value, the maximum value as the earliest start of activity B. So which one will be the value for the earliest start of activity B? 5 or 2? Remember that we are doing the forward pass. We need to select the maximum amount of between 5 and 2. So the answer is for the earliest start of activity B is 5. So now that you have the earliest start of activity B, it's easy for you and me to calculate the early finish of activity B, which is the earliest start plus the duration, which is 2. So the early finish of activity B, it's 7. Now, last but not least, we need to do the same with the activity D as in David. And it's just the same because we have the input on the previous page. So activity B, early finish, it's 7. However, activity D, which is the next one, the early start is not a problem because we have only one option here, which is take the early finish of activity C and just copy and paste on activity D. So what is the early start of activity D? Thank you so much, it's 2. So if you add 2 plus 6 is 8, which is the early finish of activity D as in David. Now, we have a question for you. What is the early start or the duration of this project on activity end? It's 7 or 8. Remember, forward pass rule, we need to select the maximum amount, the maximum time between B and D, which is 8. Thank you so much. So now that we finished the forward, step number 1, forward pass, now we are ready. We can answer some of the questions that I have for you here. So what is the earliest start of activity B as in boy? Why I'm putting this question right now in the middle of the example is because on the exam, you can have those types of questions. What is the earliest start of activity B? You cannot define the earliest start of activity B until you finish the forward pass. Another question that I just put for us to practice for the exam. What is the early finish of activity C as in Charlie? Activity C, early finish? Thank you so much. Yes, it's 2. Early finish of activity C? Thank you so much. It's 2. So now we finish with the forward pass, which is step number 1. Remember, we have 4 steps. Step number 1, forward pass. Step number 2 is backward pass. So now we will be doing the same, but on reverse. So we need to start from the right to the left, which is the backward pass. Let's do it. So as an input, because we already made the forward pass, we know that the early start and early finish and everything in activity N is 8. So we start with the number 8. So what is the late finish? Remember, we're calculating the late schedule and the bottom line of each activity. So now we have to calculate what is the late finish of activity D is 8. Just copy and paste the early start of the activity end, the same way we can do building the late finish of activity B. So it's the same, just 8. We don't have any additional options. That is very easy decision to make. So the late finish of activity B is 8. And the late finish of activity D as in David is also 8. Why? Because we don't have any additional options here. So it's very easy decision process here. So what is the late start of activity D? And what is the late start of activity B? That is simple. It's the same thing that we made before, but now instead of adding the duration, we are subtracting. So activity D, late start of activity D is 8 minus 6, which is 2. The late start of activity B is the late finish, which is 8 minus 2, which is 6. So D and B, we already did the backward pass. Now, what happened with activity A and activity C? Let me do it right now for you. The activity A, the late finish, is just 6. Why? Because we don't have another option in this case. So that is a very easy question. Just copy and paste the late start of activity B, copy into the late finish of activity A, which is 6. So 6 minus 5, it's 1. So 1 is the late finish of activity A. We have a tricky question here with activity C, is because we have 2 options. What is the late finish of activity C as in Charlie? It could be 6 or it could be 2. It could be 6 or 2 here because we have 2 different options, 2 different arrows. So which one do you think we should select from these two values? Thank you so much. It's the minimum value between D and B. Why? Let's say because we are calculating right now the backward pass. So the late finish of activity C is 2. It's not 6. So what is the late start of activity C essentially? It's just 2 minus 2, which is 0. So that's the backward pass. We'll finish the backward pass, and in the exam, you can maybe have one of these example questions here. What is the late start of activity C? So you cannot answer this question until you finish the forward pass and the backward pass. So that's why we need to understand this exercise. And remember, this is a very, very simple example. This is the minimum level of knowledge that you need in order to complete this beautiful example. So what is the late start? Late start of activity C. Late start, 0. What is the late finish? Late finish of activity D, as in David, late finish, 8. Thank you. So for the exam, you're ready to provide the right answer, which is 8. Now you know what is the late start, what is the earlier start, what is the late finish, what is the duration. That is the step number 2 for this example. The step number 3, it's another one that you need to, 6 or 2. The step number 3 is just calculate the total float for each activity. And that is the formula. So the total float formula is late finish minus early finish. That is very easy because it's just a simple transaction. So for the activity A, the total float, listen to me, pay attention. We're almost done. So the float for the activity A, it's 6 minus 1. It's just the late finish minus early finish. If I ask you, what is the float for activity B as in boy? By the way, the float is the same as slack. And what is that, let's say? Remember me, please. Remind me, please. The float is how much time you can delay any activity without delaying the total completion date of the project. That's it. To me, it's like a gift. It's a resource. It's an asset. It's something that you can use in order to make scheduling decisions. Okay, what is the total float of activity C as in Charlie? It's late finish, which is 2, minus early finish, which is 2. So 2 minus 2 is 0. What is the float of activity D as in David? It's A minus A, 0. What is the float of activity B as in baby? 8 minus 7, which is 1. That's it. So as soon as you can define the total float for each activity, for activity A is 1, activity B is 1, activity C is 0, and activity D is 0. Now we are ready to identify the critical path. So the critical path is the path that it's when you see the total flow, that activity is part of the critical path. So in this case, the critical path, it's start, C, D, end. That's the critical path. Why? Because those activities have a total float equals 0. So what is the total float of activity C as in Charlie? 0. What is the total float of activity A as an apple? 1. What is the total float of activity B as in baby? 1. So as soon as you see the total float of 1, that activity is not part of the critical path. So by definition, the critical path is the longest path of the network, and also is the shortest time in which you can complete the project. So as I mentioned, this is something that you can see. Maybe you may have 1 or 2 questions or 3 questions about this specific topic. And the most important thing is for the next class, let me know if you have any question. So before we finish, I'm just putting red color, what is the critical path for this example? So the critical path, what activities are part of the critical path? Will be start, C, and D, and end. Of course, for the exam purposes, maybe you don't need to put start and end, but just for us, for more clear explanation, it's start, C, D, and end. And what is the project duration here? It's 8 days. So this is the example that I just prepared for you in order for you to watch this video. Hopefully you can watch this video before Saturday, and just I will be open for any questions. So in that way, we will be able to move forward and be more productive the next Saturday. See you then, and thank you so much for your participation and for attending this session. Have a good one.